record on this computer. I'm going to go ahead and share my screen and get started. So we left off yesterday with the question over here. Today, by the way, I'm going to focus mainly on the programming stuff for this exam, since you did a lot of theory. So again, we're reviewing for the final. Again, that's going to be on the the Tuesday from 3 to 5, like 3:30 to 5:30, I think, or something. It's the times in the syllabus, but it's a common final, so it's going to be on the 15th. So regardless, let's get started with this. Let's go ahead and create. So here is one of my favorite problems. Create a Java method named mirror that takes a reference to the root node of a tree, of a binary tree, and creates a new tree with its own nodes as the mirror image of the tree, original tree. For example, if root is a reference to the root of the tree on the left, then return the value the return value of mirror root would be a reference to the root on the tree to the right. So if this on the left is the input, the right would be the output. And notice how it's a mirror image where 2 and 3 have flipped. 2 still has the same children, by the way. The children also flip, and their children also flip. Okay, makes sense? So hint, it's much easier if you use recursion. So we're returning a new tree with its own nodes. So let's go ahead and create a private static class node node E, which is going to contain a we're going to create an E data, node E left, node E right, and a constructor node public node E data, this dot data is equal to data. There we go. So we've got our class here. Now let's go ahead and do public, assuming I can type, public static E, and this is going to return the root of a new node, root of a new tree, mirror node E root. Okay, so given the root of a tree, we need to return okay, I will fix those. I'm because sworn I went through and fixed all of them, but I will go through and fix those. Just shoot me another email, okay? And I'll get it on my queue. Okay. So public static node E. So we've got this mirror. And so first off, let's go in through and figure out our base case. So if root is null, right, then what's the mirror of null? Nothing. So we're just going to return null. Okay. Otherwise, we need to, let's see. Well, how do we flip this thing? Well, let's see. Well, what we really do is that if I'm not null, then I'm going to flip my children. So 3 and 2 becomes 2 and 3. So what I have to do, but I have to do it for a new node. So node E new root is equal to, and we're not going to say root because that would make any changes we made to root or new root occur on the other node. It would be aliasing them. So instead we do have to make new nodes with root.data, right? And now what we'll do is we'll say, hey, all right, generic. Node, what is your warning? Useless assignment. Okay. So now what we do is we say, okay, new root dot left, it's going to be equal to whatever we had on the right side. Right? So, or rather, it's going to be, sorry, it's going to be equal to node E root dot right. So what we're going to put on the right side is what we had on the left side. But we got to make sure it exists first. But we don't need to really make sure it exists. We're going to cheat, because what we're going to have to do to our children anyway is that we're going to have to flip them anyway, right? So right 2, once we flip it, it's going to have to flip its own children, 4 and 5. So what we'll do is we'll say, hey, root.left is equal to mirror the original node root.right. And new root.right is equal to mirror root.left. And what this will do is that this will create, each of this will create new copies of the right node and left node respectively. And then do the flipping operation that we just set up. This part over here does the flip, and then that will attach them for us. And then we return new root to be done. It looks like a very complex problem, but it's actually very simple to solve once you get your head around it. Does that make sense to everybody?
So if there's no right or left root, it's just gonna
return. It's just gonna give us null, right? Because so if root.right is null, then we'll get root null that attaches, and null gets attached to new root.left.
So this one is giving us a new copy of the tree, right? If we want the original tree, what we just do, like would you just remove line 18 and?
Pretty much.
Okay.
I mean, you'd be swapping. You wouldn't have to also do the recursive call. Well, you wouldn't want to do the recursive calls in the same way, but it's better to create a copy. All right. So what is the running time of this algorithm that we just wrote? What was the big O of this? It is O of n because we are touching every single node once. Every single node gets touched once by this. So let's go ahead and see. Do we have any other practice problem on this exam? Not really worth looking at. So see. Now, let's see.
Professor Rosen, I had a question. So when you have like recursion, how would we determine like the big O in those problems? Because it gets confusing when you deal with recursion.
In 3223, we cover how to specifically find that out using something called the master theorem. But in these cases, you got to think, does my algorithm touch everything? Yes. In sorting algorithms, we have this case of you have to really draw it out and see how many layers it has. And we'll find that it often gives us, you'll find that recursion either will end up with, at least in this class, it'll be log n, n log n, or n. And most of the time, if it's n, it's fairly obvious. And then if it's log n, it's fairly obvious. So n log n is less obvious, but you can kind of deduce from that it's probably n log n.
So the log n would be when we do like binary search with recursion. That's how.
Yeah, binary search is log n. N log n is when you've got is something like quicksort or merge sort, where you have log n layers, or you have, or your recursion goes log n layers deep, and each layer takes n amount of work. Make sense? Okay. Now this question over here, now this exam unfortunately doesn't exist anymore, but I do remember the question that I was super interested in, that I like this one for. It was a good coding question. It said here, given a, it was given a bunch of username, a text file, okay? Given a text file that looks something like this. Oh, sorry, this is not Python. So given a text file that looks something like this. I'll explain what this is in a second. So what this is login entries. So suppose this is a login entry file on the server where the first field, so it's a text file, and each line has two fields, okay? Following me so far? Text file, two fields. The first field is the username of the user who logged in, and the second number is how long that login lasted. Make sense to everybody? In milliseconds, let's say. I know it's not very, these are not very long times. Okay, so username and how long they were in for. All right. So the problem is, I want to know what for, given this input file, what is the average login time for each user? Make sense? Does everybody understand the problem I am asking? Go ahead and put yes or no in the chat especially if you don't understand.
I understand what you're asking.
Cool. So this is a file. So let's go ahead and let's assume we get the file name as a string as our input. So we're going to do public static. Now, to return the averages of a bunch of things that we don't necessarily know, we're going to need to return a map. Map of, and let's go ahead. And so now we have to figure out what kind of map it is. We're trying to figure out the average amount of time for each user. So that would be a string, would be the key, and the value would be a double representing the average amount of time. And then now we're going to say string file name. And then I'm going to say throws exception right over here, just as kind of a nice little thing so that I don't have to worry about exceptions. Import java.util.star, so I can just, have everything. So I can have map and hash map. So this, okay, and now I'm going to go ahead and quash the error, return null. Okay, so all right, so now, so what do we need to do to keep track? So how do I figure out what the average of something is?
You add them all up the instance and divide it by the number of times they occurred.
Right. Now, we want, for Alice, we would only want to add 1341, 134, and 21312 and divide by 3, right? We only want to average her times because we care about the average login time for her, right? So since we have multiple people, we need maps. So we're going to create one map from of string, the username, to double for the number of times they have, for the number of times they've logged in. So not the number of times they logged in, the amount of time. Login times is equal to new hash map. That will be the amount of time each of them log in. And then, okay. And now map double from a string to an integer, num logins. And this will basically say here, given this user, here's how many times they logged into the server. Make sense? We're still going to have to return null at this. And now we have to go through and we are going to just simply, I'm going to also simply say list of string. Let's see. I'm trying to think of a good way to do this. And in Python, it would be so easy, but yeah, no, it will just have to do this line by line inside of inside this. So scanner is equal to new scanner, new file name. If I recalled correctly, that should be how it works. Right. And now while scanner dot next line, or sorry, while scanner dot has next line, while we can still read a file, what do we do? Yes, it says we need to put it into a try catch block. So it doesn't like the fact that we did that. So throws exception. So while scan try, so we're going to put this into a try catch block. Try catch exception E. I have to fix this a bit. Try catch exception E. And what are we going to do if we get an exception? Going to be really lazy. Return. Not going to return null. I'm going to return something even more useless. New hash map. You can figure out what the type is, Java. Thanks. Try with resources. Oh, and it wants me to close it. Finally. This linter is being very annoying. I don't know how to do a try with resources. Honestly, I'm just going to go with my what I had earlier. It's more readable. Okay. While scanner dot has next line, and then scanner dot close at the end. There we go. That quashed that error. Scanner.has next line. What are we going to do? We are going to ring the line. String line is equal to scanner.next line. Okay. And now that we've got that line, we need to split it. String fields is equal to line.split. What are we splitting on? There's a space between each of those items. So that's what we'll split on. Okay, we've got our fields. And so string username is equal to line 0. And then not line 0, fields 0. And then string, and then int time is equal to fields 1, except of course we have to convert it. Integer.parseInt. I don't know what you just did there, but okay. So now we've looked at a line and we see, hey, here's the username and here is the time. So what we can do is we need to ask ourselves, hey, have we seen this user before? So let me see if I can remember. If username, or let's see, if num logins dot contains key username. Let's actually go with not it. So if this is the first time we've seen this username, okay, if this is the first time we've seen this username, then what are we going to do? Well, if it's the first time we've seen it once now, so that means they've logged in at least once. So num logins be equal to num logins is equal to, sorry, dot put username and 1. So we've seen them once, and we should do num login, sorry, and we should do login times dot put in the username and the time, the amount of time that they took. Now what's happening over here? It does not like the fact that I am putting in an int and it wants a capital D double. So here's an interesting thing that you may have encountered or may not have. Right? Ints will convert to integers automatically. Doubles will convert to class capital D doubles automatically, but it doesn't work the other way around. Ints won't convert to class D to capital D doubles. So easiest way to get around that is double time. And then we're just going to do double dot parse double instead of parse int. And that's it. Because any integer can be parsed into a double. So now that's been put in. But that's if we haven't seen it before. If we have seen it before, in that case, what we're going to need to put in is a bit different. In that case, we'll want to get num. We're going to want to put in num logins dot get the username plus 1. So in other words, get the amount of times that we've seen this add 1 to it, and then put that into the map. Same thing over here. Login times dot put, sorry, dot get over here, the username, get the amount of time we've already seen, and add in the new time and put that back in. So we go ahead and we populate these maps, and we're good. We're good to go. Okay, so we've got the number of times for each person. We've got the number of logins for each person, but we're not quite done because we need to calculate the average. So let's go ahead and make our final map averages. And let's go ahead and define it as a string to strict math, string to double equal to new map, new hash map. Okay. There we go. And oh, sorry. And now we'll want to be able to return it. Averages. For what was it? String key in num logins dot key set. So for every, let's call it user. For every username in our key set, in other words, for every username we've seen, we're going to do averages dot put. We're going to put in key. So we're going to put in the username as the key, and then the value is the average, which would be this nice big thing we're going to have to put in, which is, well, an average is the amount of things that we're looking at, the type of thing we want to average up. So login times dot get the username for that divided by the num logins dot get username. And there you go. And now it's telling me to use entry set over key instead of the key set. No, I think I'll do this. Thank you. Okay. So that's that problem. So on your exam, there will be one, if I'm remembering correctly, the way I've written the programming. There should be one or two tree problems, a hash map problem, and a linked list problem. I'm just trying to remember specifically what I wrote last semester, but you can expect one of each of the big ones that we've worked on. Now, the linked list one, right, won't be too difficult. It's not like you have to manipulate the individual pointers in a linked list like you've had to individually. It's more like, I want you to do this linked. I want you to take two linked lists and do something with them. And if you've been keeping up with all your data structures, is actually quite easy to do. So any questions about that? Now let's take a look at some more theory stuff for right now. So I also just want to kind of just let you pat yourself on the back a bit here. So in Japan, the way stuff works is that you've got a is that they're big on entrance exams. So if you want to get into computer science grad school, you need to take a computer science entrance exam. So this is the exam from 2017 for University of Tokyo, also known as Todai, which is like the best university in Japan. It's a public university. The public universities are actually considered to be a higher tier than private universities for some reason. That's what I hear. I might be completely wrong. But anyway, this is the entrance exam for that year. Hi, Annie. What's up? Okay. So notice that it is 4 problems and you got 2.5 hours to do it. And of course, they do it at 10 a.m. because of course they do it at 10 a.m. I don't know if you'd prefer to do exams on the morning or the afternoon. But anyway, let's take a look at this. 4 problems, use the designated answer sheet, put in your name, right? Right? And of course it's in English and Japanese. So first question, first off, they're big in math in Japan for computer science. So this is just kind of stuff you would take if you had done heavy mathematics. They define something called a p-norm, and then they give you some scary looking math, which is part of the point of scary looking math is that it just looks scary. It's not actually that hard. But that's not this. Number 2, this is from automata theory. This is actually, here is a language that defines something called a non-deterministic finite automata. In other words, it gives you a flow chart. In other words, here's the language for a flow chart. Here is, give us something that satisfies this these conditions for this flow chart. It's really not as hard as it seems. Again, it's math. It's scary looking math that just exists for the sake of looking scary, in my opinion. Problem 3, though, this should look much more manageable. Oh, and problem 4, by the way, is it has to do with hardware, right? So they like to do like a math question, an automata question, a hardware question, and then this one on data structures. So consider the problem of sorting an array of integers using the heap sort algorithm. Assume heap sort brings the minimum element to the front. So in other words, we sort from the smallest to the largest, a bit of a clunky way to saying it. Answer the following phases. Heap sort consists of 2 phases. Explain is what is to be performed in each phase. So what are those 2 phases?
So finding them. So in this case, would it be the min heap and
max heap? You create the max heap, and then you remove, and then you build the array in reverse.
Oh, I just read that it said heap sort brings a minimum element.
Right. Well, it's the heap sort, the actual heap sort algorithm when you're done sorting.
Oh, I see. So yeah, the heaps. So the first step was max heap, and then putting that in the array, and then just keeping it on the last element, the max.
Right. You do heapify, and then you actually remove elements and slap them on the end until there. So consider the following array using heap sort. Draw the tree structure after the first phase, which is I was worried I wasn't sharing. So after the first phase, which is after turning it into a max heap, right? So we know that, which is how do we turn this into a heap? A max heap. So let's go ahead and do 3, 8, 5, 1, 5, 4, 9, 7. All right. So to get this as fast as possible in heap time, sorry for this, and I think I go over this in the videos, but you might have missed it. It's okay. What you do is that you start from the bottom, and you push down each item to the point where it needs to go. So, and we start at the bottom. Now, in this case, remember, the smaller the number, the heavier it is. So push down, it's bedrock. Push down, that's bedrock. Push down, it's bedrock. Push down, it's bedrock. In fact, we can just skip this entire first row, this bottom row. Now we just got to push. Now we push this guy down. So we're going to push 1 down. It's smaller than both its children, so it's heavier than both its children. And now the lighter item needs to come up. So lighter in this case is 9. So 9. and 1, and then over here 8 needs to be 8 is heavier than both 5 and 4. That's good. And now we've got 3. 3 needs to be pushed down so that the heavier item comes up, which again, heavier is bigger in this case. That's just how I try to think about it. It may not be the perfect metaphor for you. And now we got to continue pushing this guy down. So, and again, it's a max heap. So we're going to swap with our largest child as opposed to our smallest. 7 and 3. And there we go. That's a max heap. That's that second question done. What is the time complexity of each phase when sorting an array of log n? So the time complexity for this guy is of each phase is O of n and O of n log n. So let's talk about this last phase, which is sorting. Okay, before we go on to this phase. Sorting is n log n. Why? Well, what do? We remove the top item, and then we have to take this bottom item up to the top and reheapify and return it back into a heap phase. We know that removing an item from a heap takes how long? Removing a single item from the heap takes how much time?
Log n.
Takes log n. How many items do we have to remove? There's n items in the heap, so we're removing n items. Each item takes log n time to remove, so we get a grand total of n log n. That's it. That's as simple as it gets for runtimes with n log n. We've got, now the question is, how long does it take to do, now as far as turning it into a heap in the first place, that takes that actually takes n time, and the analysis on that is actually fairly complex according to our Wikipedia. But if we were just building a heap, it would take, just by adding one item at a time, it would take n log n, because we'd have n items, and then adding each item takes n log n time. But over here, because we kind of skip half the array, over here we kind of get to, it makes it much easier to do. You can look it up on Wikipedia or in the textbook as to why that works so much faster. So let's see. So let's go ahead and look at this one, at question number 5, which is the kind of question I like for our kind of finals, which is, we have heap sort. It's often larger than that of some other sort algorithms, such as quicksort and merge sort, when you're solving a large array. Why might that be? Why might heap sort be a weaker choice for a large array than quicksort or merge sort? It's not, it's just the way that we presented things, I think. N log n stuff is that's because it's because every single divide and conquer algorithm that we've learned is n log n. So, let's see. Now, why would we want to use this over why would this be slower than quicksort or merge sort? Anyone? They've got the same big O runtime, right? N log n. So what makes this one possibly slower? Hold on. Anyone? So the answer is because of what we wrote earlier. It's this two phases that take O of n time to create the heap. You have a distinct phase of O of n time to create the heap that other stuff doesn't have. And that linear O of n time can mean that it runs a bit longer. So congratulations, you can answer 25% of the graduate school questions for an entrance exam. Let's go ahead and see if there is, let's see, is there 2018? Can we just do that? Yes. Let's see what we had over here. find and merge operation for sets and subsets for tree. So this one has a forest of trees kind of stuff. So stuff that you would learn in the next class, I think.
Professor Rosen, I have a question.
Yes, what would
so we have the two phase, which is the first thing we build the heap, and that takes big O of n.
yes.
And then finding the maximum of that heap is log n, right? And that's
right.
log n.
And we do that, and we find that maximum. It's not finding the maximum, but removing the maximum takes log n time. And then we have to remove log n items.
So why is it log n to remove it and not find it? Aren't you?
Because to find it, it's constant time. It's to find the biggest item, you just look at the top. To remove it, it takes log n time.
So the log n time is to put it at the top, or?
No, the log n time is to remove it from the heap and move it to the back of the array.
Oh. Okay.
Okay. All right. So let's go ahead and take a look at this one. So in the course, we've seen many different data structures. Hi, Laser. Including the following. We've got lists, linked list or array lists, two-dimensional or higher arrays, stacks, queues, hash tables, trees, binary search trees, undirected graphs, directed acyclic graphs, which are DAGs or graphs that that basically don't have any cycles in them. Okay, so for each of the following, please tell me what the most suitable data structure is. You will have questions like this. They will be multiple choice though for ease of my grading. So tell me what the best data structure for each scenario is. Okay, so you've got a map of the Puget Sound highway system used to display traffic times on a web page. The map displays principal cities, intersections, and major landmarks, the roads that connect them, and travel times along those roads. Travel times along the same road may be different in different directions. So what is this data? What data structure would you use to model this?
Directed graph?
Yeah, directed graph. So in this case, what are the nodes? What are the vertices in directed graph?
Cities or principal cities?
Yep, principal cities, intersections, major landmarks. Those are all vertices. Anywhere that you might want to get to is that. And what is the edges? What are the edges? In this case,
It's the connector, right?
Yeah, it would be the roads. Yeah, that connect them. And what are the weights for those?
Time it takes, I guess.
Yep. Remember, all graphs they define relationships, and since relationships are one of the most common things we model, graphs are very versatile. Okay. So what is a chessboard? What is the best way to model a chessboard? Or what is a good way to model one?
2D array?
Yep, we've seen that in our assignments, in fact. 2D arrays are pretty nice and concise. A computer model showing the dependencies between steps needed to assemble a Boeing 787 airplane at Boeing's Everett plant. This one's tricky because it's only something we just learned. Gut check. Is this modeling relationships or not? Is it modeling a relationship?
Yes, it is.
Right, it is. The relationships are So you're, in this case, it would be, so if we can rephrase it as a graph, let's think about it. What are the nodes? The steps. What are the edges? The dependencies. So in other words, we need to do this step before doing this step. That's a relationship that can be modeled by the graph. The edges are those dependencies. So what kind of graph are we using?
This is the acyclic one because we have to use that topological sort.
That's exactly right. It's a directed acyclic graph because if there's dependencies, you have to do something before something else. You can't have any cycles because otherwise you're just kind of like, you'd be like, where would I begin? You know, I have to, you know, I have to have a chicken before I have an egg. But in order to get a chicken, I have to have an egg so it can hatch a chicken. But in order to get an egg, I have to have a chicken to lay the egg. But in order to get a chicken, I have to hatch a chicken from an egg. Right? That's a cycle right there. So directed acyclic graph says none of that nonsense. In fact, anything that do with dependencies or dependency graphs or relationships or requirements, that can be modeled by a directed acyclic graph. All right. A list of legal words in the Scrabble game. We want to quickly be able to check whether the words used by the players do in fact exist in the list. So saying list over here is kind of telling you it should be a list, but maybe not, right? Because if we want to do it as quickly as possible, what data structure should we use?
Hash maps?
Hash map or hash set. A hash set is really useful, is what we want over here, because we just care about the keys. We don't care about values. We just care, does the key exist? So in that case, you just have a set of all the words.
If you wanted to store the points alongside them, would that be a good time to use a map?
Oh yeah, totally. That's an excellent example of using a map. If you were to answer it, if I were to ask this question on a paper exam, remember these are going to be multiple choice. If you were to ask these questions on a paper exam and your answer was map, key, word, value, number of points that word is worth, I'd give you full credit. Even though it's not, because you would have turned a wrong answer to a correct answer. Because under the system you've created and interpreted, that makes complete and total sense. All right, description of inheritance relations between classes and interfaces in a Java program. So this one sounds like it would be a directed acyclic graph as well, but it's not. Because yes, it's a tree, because you can only, because of the way it extent things happen, or the way things are arranged in Java. It's a hierarchy with object at the top, and you can only inherit one, and you can only extend one class. So, but many classes can be extended from the same parent, so it's definitely a hierarchy. So I just dropped my pen and now I can't find it. I'm like losing everything. It's like I've got a mini black hole near me, or a portal to another dimension, and I'm not sure what's going on. I didn't mean to stop screen share. I meant to stop the annotation. Okay. So this one I think is actually the weakest question they have. A history list recording sites visited by the user of a web browser. As new sites are visited, they are added to the list. The list also supports the operation of going back to the web page that was previously visited before the current page and going forward to the next page visited. So in other words, these two buttons over here, the back and forward button, what data structure would you use to implement them?
Could be wrong, but a linked list.
I would use a linked list, yeah. I definitely a linked list, because you're just going back and forth between that, and that takes constant time to do that. The other thing I would accept is if you use a stack for the back and a stack for the forward. So basically, each button has a stack, and the top of the stack is the most recent thing that you need to flip back and forth between. All right, let's see. Oh, another coding question. The nodes in a binary tree can be represented by the following data structure. Blah, blah, blah. It's a binary tree. Complete them definition method a BFS to perform a breadth first traversal of a binary tree and print out the data in the order they reach during the search, right? So yeah, seriously, where'd my pen go? It would have been really useful not to have dropped that, but I did. Ah, there it is. Guess it didn't fall into a black hole of some sort. So if I've got a binary search tree, let's go ahead and draw. Suppose I have this binary search tree, 7, 5, 15, 2, and 6, and 10 and 20, then the order I'd want to print stuff out in, if I did this, was 7, 5, 15, 2, 6, 10, 20. Okay, because we're doing breadth first search and not any of the other searches that we've done previously, right? Not post order, pre-order, or in order. This is breadth first search. Now, because it's a tree, it's kind of saying, it kind of screams, I've got to do recursion. But what data structure most best aligns with a with breadth first search? Right? Depth first search uses what data structure if we don't use recursion?
Stack.
Yep, stack. Depth first search is stacks. Breadth first search is queues. And when we do depth first search, right, if we do it recursively, we're still using a stack anyway. We're just using the runtime stack. So in this case, we're not going to do recursion or stacks. We're going to use a queue. Public. Static. Node. E. We're going to use node. Oh, wait, no, it's going to be a void method. E void BFS, which in the context of Dungeons & Dragons would mean a big freaking sword, I guess, but it's neither here nor there. Node. I just miss playing Dungeons & Dragons with people. It's sad I can't get in touch with them in person. Let's go ahead and do root, assuming I can spell it. I don't know why I'm having so much trouble spelling today. All right, so what we're going to do is we're going to create a queue. This is even simpler than what we would need to do for graph because there's no risk of back edges or anything. No risk of us hitting edges accidentally or accident. Let's see. You know, you're the second person who suggested Roll20 for me.
I definitely recommend it. I miss IRL games, but it's good if you had a good people around.
We really don't do much dice roll other than basic dice rolling. We're not big. Most of the parties I do these days, we don't do a lot of combat. We do a lot of let's just say that we prefer that if we when we fight, we prefer it to be over very explosively in the first round. We otherwise we try to talk our way out of stuff.
Very 5e of you.
All right, so let's go ahead and create a queue of nodes. And because a queue is an interface, we'll do new linked list. So Ryan, look, it's just that we bend the rules a bit too much. Like, so, you know, giant dragon tries to eat you, right? Let him eat you. What happens if you polymorph when you're inside the dragon into, say, like a Tyrannosaurus Rex? You know, rules don't account for that.
Rules is written. He would actually take massive damage. That's a good thing. That's good.
But the damage is fine. Damage is fine. Why does it not want me to do it like that? Okay. In my queue of nodes. Oh, I forgot to put in a variable. Queue. So what we got to do now is basically what we're going to do is say while root. Sorry, I'm going to say node E current is not equal to, sorry, is equal to new node. Here I am getting distracted by Dungeons and Dragons. While root, well, current is not equal to, let's see, we'll figure out our condition in a second. So let's go ahead and figure it out. Oh, and current should be a new node. It should be root to start out with. So, yes, this is what we want to do. Q dot add. We don't need a current there. We need just Q dot, what is it? How do you, I forget how you do it. Offer a node. Let's go ahead and offer the root node. And so now the root node, so we create a queue. The root node is the first thing in the queue. So the first thing we do then is that we say while queue dot is empty is false. So while the queue is not empty, we're going to say current is equal to queue dot pull. We're going to get the node out of the queue. Why are you so angry with me? Look at it. It's just so upset with what I'm writing, and I'm not sure why. Add an end condition to this loop. I've added an end condition to this loop. While queue is not empty. Oh, semicolon. That's what I get for using Visual Studio Code as opposed to IntelliJ. So we've got current is equal to q.poll. So now what we do is that it has up to 2 children. So if current dot left not equal to null, q dot offer current dot left. So if it exists, put it in. Copy paste. If the right doesn't exist, put it in. If it was on paper, if you were doing this on paper, I would just, and didn't have access to the copy paste operation, I would just simply do, I would say it'd be totally fine for you to say same for current dot right, and I would know what that meant. And you could just do dot same for current dot right on paper. I'd be perfectly fine. Put it in the left, put it in the right if it doesn't exist, and now we need to print it out. Let's see, does that work? Source to HTML converter. No, that is not what I wanted, Java. Print line, and we're going to print current dot data because that's what we care about, the data inside of it. So what we're going to do is that we would put it into the queue. If we have children, we get it out, the first thing out of the queue, add the children to the queue, and then the next, and then print it out. And then we'd go on to whatever the left was and add its children, and then the right of the original and then add its children, and so on and so forth. Excuse me, I gotta go. I hear Laser crying. I gotta go and check on him.
He's fine, but he threw a toy, and I told him that he couldn't play with toys while he took a break to think about why it's not good to throw toys.
Is he out of toys for all today?
No, just until he thinks about it.
Okay.
I handed him something off of the bed,
What did he throw?
the wooden train whistle.
That could hurt somebody. He is fine. He is learning. He is having trouble learning impulse control, like don't throw your toys when somebody hands it to you to see what happens. So he has just simply had his toys taken away from him while he's and put on a break from toys while he thinks about what he did. So, and obviously he's very upset about this. All right. Let's see. Insertion. Yes. Here's a good question. Two of the most common divide and conquer sorting algorithms are quicksort and merge sort. In practice, quicksort is often used for sorting data in main storage rather than merge sort. In other words, it's used for sorting stuff that needs to be swapped around on the disk. Why would you use quicksort over merge sort? So, any answers? How does merge sort work?
Doesn't merge sort like split the data and then sort the splits and then merge them?
Yep. And where do you put those splits?
I don't know. You put them back in the disk.
Well, I mean, when you create your splits, where are those created?
In arrays.
Yeah, new arrays, right? You have to make new arrays or new things for your splits if you're doing it with arrays, right? So it uses O of n extra memory, right? What about insertion sort? How much extra memory does it use? Quicksort does everything in place. So the only extra memory it will use is any additional memory on the stack, which to keep track of where it is, which is not much at all. So that's why quicksort is preferred, because when you're working, because you can do everything in place with quicksort. Let's see. So quicksort's worst case running time is O of n squared, but on average, right? It has an expected running time of n log n if the partition function works well. So what needs to be true about the partition function in order for the running time to be n log n? So what does the partition function have to do in order to ensure that we get an n log n for quicksort? Anyone?
This could be wrong, but I'm guessing the partition has to divide it evenly, if that makes sense.
Yeah, that totally makes sense. That if the more exacting answer would be that you have to select a pivot such that you've got relatively around half on the items can be sorted to either side of the pivot, right? Make sense?
Yeah.
So in practice, how do you make sure that this happens? Because if you select the first item, right, that could be an issue. If you just select the first item, that could as your pivot, that could you could get some bad pivots. So how do you get so the question in practice, how can we ensure this happen is asking. Sorry. How can we ensure this happens?
Base the pivot location off of the max length. So
Okay.
that way we make it a fraction of the max length. It always works.
I don't really see how that would help. what you're looking for is that if you want an item that half the stuff is less than and half the stuff is greater than, right? What item, what in a list, in a ordering of numbers, what do we refer to that number as? The number in the middle of the data.
The average.
Not the
Median?
yeah, the median. The median. So you want you want something that's the median value. Okay? But finding the median itself takes a bit of time. So what we'll do is we'll cheat, and we'll take basically, and the book explains that basically the way we cheat is that we look at the first item, the last item, and the middle item, and we choose the median of those three as the pivot. So that's one way to do that. Finding a median is actually a bit tricky. That's covered in 3223. But once we can find the median, then we can actually ensure this works much better.
I have a question. So how do we find it? So we got the first element, last element, and the middle element, and we found the median of that?
Of those three, right? You've got three items. You figure out which one you want your pivot, which is the one in the middle.
So we just resort them into
Yeah, you just sort those three. You just simply swap around those three items, which takes constant time because you're only doing it with three items. All right. So, okay. So for this, I think we are good. It is 12:07. I'm sorry that I'm not on my top of my game for this last class. My mom texted me last night to tell me that my sister is in the hospital with double pneumonia. So, and especially with the COVID risk going on, and she hasn't gotten her test results back. So I've been very worried about that. So I do want to just emphasize that do your best to maintain social distancing. We will get through this soon because vaccines will be on the way. The UK just approved the Pfizer vaccine. But it's just very important to. So, but anyway, I'm just sorry. I'm just not at the top of my game today as terms of for this last class. Now, before I sign off for our last class, do you have any questions you want to ask me?
I have a question. Don't we have lecture on Monday though?
Oh, right. We would have a lecture on Monday. I totally forgot. We do have a lecture on Monday. Yes. So this is not the last class. My bad. I thought, right. Tomorrow is my last class for my other class, right? Yes. Let's go ahead and just double check when the final is since we have more time. Man, I was feeling like I had a rush today, but I completely forgot that we had Monday as well. Okay. Right. So let's go ahead and screen share one more time. Okay. So let's go ahead. Screen share Mozilla. Temple final exam schedule, right? Remember, any class over here, go and click on this, fall 2020. Right, you can find that over here under exam schedules and clicking on the fall 2020 link. Yeah, he's really upset. All right. And you go to and look for the respective courses, but notice that we have common finals as well. This is a common final. That means that you'll find it over here. All common finals are 3:30 to 5:30, and it says 2168. If you're in 2168, you have a final exam on 12:15. From 3:30 to 5:30. 12:15, of course, being a Tuesday. Makes sense for everybody?
Another question. What about the leftover demos? Can we still demo them, or is it?
Yes, you'll be able to demo them. If you need a demo to your arrange with your TAs to demo. Ryan, do you mean complacent, not as opposed to complicit?
I do mean complacent. Yeah, don't get super duper.
No,
it's not over. It's not over at all.
No,
I'm sorry.
The light is but you can see the light at the end of the tunnel, and it's not an oncoming train for once.
True.
Okay, that's what I'm saying. And yes, right now that we voted, the Vaccine Council has voted that we are, or the CDC Advisory Council, I forget what they call it, but they voted to say who should get it first, which is of course healthcare workers, because if your healthcare workers are getting sick, then you're losing people to treat people, which obviously that's just kind of like a vicious cycle there. And the second one is the I will answer those questions in just a second. And then people in nursing homes, because people in nursing homes account like for what, like 6% of all cases, but like 40% of the deaths. So in the US, that makes sense, I guess, to distribute to them. And right, there are the issues of storage and limitations and stuff. The storage limitations are difficult with that, but then we have other vaccines like the AstraZeneca vaccine, although that has some data issues with it. So, so now Mariana and Arun both ask very similar questions. Can we use the internet on the final? And do we have access to our IDEs on the final? And the answer to both is yes. It's just the final exam is just like the midterms. Okay. And the line, so again, I have a very clear line, which is anything that's not human interaction is completely kosher. So again, that line is it's okay to read something on Stack Overflow, but the minute you make a post on Stack Overflow or Chegg or some other of those websites, which we'll be looking for, in that case, then we are going to, that's where we get into issues. Okay. Now, so again, the internet, and again, I will have for my class, the late penalty of 0.1% per minute late, 0.1%. So of course, an hour late, 6% off. So if you need that extra time, you can have it. I would just highly recommend, though, studying for this exam, because a lot of students come into this exam completely burnt out and not having studied for it because they were studying for other stuff. So worst case scenario, I would make sure you study for this. Okay. All right. So that's.
I'm sorry.
Go ahead.
Asking the late penalty is going to be the same as the midterms, right?
Yes, exactly. Exactly. All right. So that's what I've got for today. I will see you on our last class on Monday.
Thank you.